Determine the intervals within the given interval from 0 to 2 pi, including 0 and not including 2 pi, for which the given function is continuous. We are given f of x equals e to the power of sine x divided by the sum of 3 and 6 cosine x. To find the intervals for which the function is continuous, we'll determine the values of x where the function is not continuous and exclude those values from the given interval. Let's first start with the numerator. The sine function is continuous over all real numbers, and the output of the sine function is a closed interval from -1 to +1, which are all valid inputs for the exponential function with base e, which is also always continuous. And therefore there are no restrictions based upon the numerator, but now let's focus on the denominator. We know division by 0 is undefined, which means the function will not be continuous for the values of x where the denominator is equal to 0 in the given interval. So let's set the denominator equal to 0 and solve for x. So we have the equation 3 plus 6 cosine x equals 0. Again, the solutions to this equation will be the values of x where the function is not continuous, and we'll have to exclude those values from the given interval. For the first step, we'll subtract 3 on both sides, which gives us 6 cosine x equals -3. Next, divide both sides by 6. Simplifying, we have cosine x equals -1/2. Now we could stop here and find the values of x or the angles in the given interval where the cosine function value is -1/2, or we can continue and take the inverse cosine on both sides. I'm going to go ahead and take the inverse cosine on both sides. Simplifying on the left, inverse cosine of cosine x equals x. We have x equals inverse cosine of -1/2. We're still looking for the angles x in the given interval where the cosine function value equals -1/2. Having a cosine function value of -1/2 should remind us of a 60-degree or pi divided by 3 reference angle. Notice the cosine of pi divided by 3 is equal to the ratio of the adjacent side to the hypotenuse, which is 1/2. But because we're looking for the angles where the cosine function value is -1/2, we need to remember on the coordinate plane, cosine theta equals x divided by r, which indicates the cosine function value is negative where x is negative. This indicates we're looking for the angles in the second and third quadrants in the given interval where the cosine function value is -1/2. To do this, we'll sketch a pi divided by 3 reference angle or 60-degree reference angle in the second and third quadrants. So for example here, where the reference angle is pi divided by 3, as well as here in the third quadrant, where again the reference angle is pi divided by 3. Let's go ahead and sketch the corresponding reference triangles. In the second quadrant, where x is negative and y is positive, we label the short leg -1, the hypotenuse 2, and the longer leg positive square root 3. In the third quadrant, where x and y are both negative, the short leg is -1, the hypotenuse is 2, and the longer leg is negative square root 3. Notice for both reference triangles, the cosine function value is -1/2. And now to find the angles in the interval from 0 to 2 pi that have a cosine function value of -1/2, we start along the positive x-axis, rotate counterclockwise to the first angle in quadrant 2, which is here. This would be pi divided by 3 radians less than pi radians, or 3/3 pi radians. 3/3 pi radians minus 1/3 pi radians is equal to 2/3 pi radians, or 2 pi divided by 3 radians. The angle in the third quadrant is this angle here, that is pi divided by 3 radians more than pi radians, or 3/3 pi radians plus 1/3 pi radians, which is 4/3 pi radians, or 4 pi divided by 3 radians. These are the two angles that must be excluded from the given interval, because this is where the given function is undefined and therefore discontinuous. Everywhere else, f of x is continuous over the given interval. So for the intervals for which the function is continuous, we'll start at 0, and 0 is included. And then we'll stop the first interval at 2 pi divided by 3 radians, and we do not include 2 pi divided by 3 radians, and therefore it's open on 2 pi divided by 3. Union, The next interval is from 2 pi divided by 3 to 4 pi divided by 3, and this will be an open interval, meaning we're not including either endpoint. And then finally, the last interval is the open interval from 4 pi divided by 3 to 2 pi. These are the intervals within the given interval for which the given function f of x is continuous. I hope you found this helpful.